So up to now we have studied Kepler laws. Okay, so there are three Kepler laws. In that, first law is that also called as a law of orbit. In that, Kepler tells us that every planet revolves around the sun in an elliptical orbit with the sun at one of the foci. That is the Kepler first law statement. Then we have also studied Kepler's second law, that also called as the law of area. In that, Kepler tells us that the line joining planet and sun sweeps out equal area in equal interval of time. Means aerial velocity of a planet for the particular time always remains constant. That is the Kepler's second law. And Kepler's third law is also called as the Kepler's law of period. Okay, so in that, Kepler tells us that the square of period of revolution of any planet around the sun is directly proportional to cube of distance between planet and sun. So T square is directly proportional to R cube. Okay, so Sir Isaac Newton studied Kepler three laws. Okay, and after deeply studied Kepler laws, he think over on it, and then he proposed his theory, that the Newton's law of gravitation. In the Newton law of gravitation, Sir Newton tells us that there is always exist force of attraction between any two massive bodies in the universe. Okay, so if you consider any two massive bodies, then there should be exist force of attraction. So that force is directly proportional to product of their masses and inversely proportional to square of distance between them. Okay, so by studying that, we have to study now next topic, that is the uniform circular motion or magnitude of centripetal force. Okay, so after studying this topic, we have to conclude it this: what force of attraction is directly proportional to, inversely proportional to square of distance between planet and sun. Okay, so what we have to study actually? Circular motion and magnitude of centripetal force. Okay, so now we are already see the definition of circular motion. In that, we define circular motion as motion of an object around the circumference of circle. Okay, if any object moving on the circumference of a circle, then that motion is simply called as a circular motion. That part we already studied. Now we one part also studied there. For a circular motion, one force is important. Okay, without that force, circular motion is not possible, and that force we call as centripetal force. Okay, so mathematically we formulate centripetal force as mv square by r. We can prove it. Okay, but directly now we have to use this formula here. Okay, so mv square by r is a formula for a centripetal force. Okay, now here we have to consider one case, that one planet revolves around the sun in an elliptical orbit. Okay, means simply we have to consider that the planets perform circular motion. Okay, now we consider one case. In that, what case you consider? That planet is in circular motion. Okay, so in motion means it has somewhat velocity. Suppose v is the velocity of that planet, m is mass of that planet, and r is radius of that planet. Okay, so that planet is in circular motion. Now there should be exist a centripetal force. That force is given by the formula mv square by r. Okay, now we consider t. T is what? Period of revolution of that particular planet. I already told you in Kepler's third law, period is what? Time taken by any planet to complete one revolution around the sun. That is nothing but the period of that particular planet. Okay, so what? V is the velocity of that planet, m is mass, r is radius of that orbit of planet, and T is what? Period of revolution. Then we have to calculate speed of that planet. That speed, we know formula of speed, that is the distance upon time. Distance covered divided by the time taken. So now it is a circular motion. Okay. Now in circular motion, to complete one circular path means what? Period. The distance will be how much? Circumference of circle. That's nothing but the 2 pi r, circumference of circle. That much distance that planet have to travel. Okay. And now T is what? Time to complete one revolution. So that is the formula of a speed of a planet around the sun in one particular orbit. 2 pi r divided by T. Okay. Now velocity will be equal to 2 pi r divided by 2. Okay. This is the formula of velocity of that planet which revolve around sun in a circular orbit. Now we know formula of a centripetal force, that is the mv square by r. Okay. We know that formula. So we write here formula force, that is the centripetal force is equal to mv square by r. Okay. Now but we got here formula for v. V is what? 2 pi r divided by t. So instead of this v, we have to put 2 pi r by t. Okay. So m into v square, instead of v square we have to put 2 pi r divided by t, and it is square divided by r. Okay. So it will be 4m pi square r divided by t square. So now here we have to make one mathematical adjustment. For that we have to multiply and divide by r square. Okay. We have to multiply divide by means no effect. Multiply divide by, both term will get cancelled. That should not affect on this equation. Okay. So multiply and divide by r square, then equation will become 4 pi square m divided by r square, r cube divided by t square. Okay. So we take this r cube by t square separate, because in Kepler's third law we already studied t square is directly proportional to r cube. So we take t square by r cube is equal to constant, and we called it capital K. Okay. So here, but here what? R cube by t square. In Kepler's third law we studied t square by r cube is equal to what? Constant. So this is inverse ratio actually. Okay. So here r cube by t square will be equal to 1 by k. That equation we have to put here. Okay. Because r cube divided by t square is equal to how much? 1 by k. That we have to put here. So the equation will become centripetal force is equal to 4 m pi square k r square. Okay. Where m is the mass of that particular planet, then pi is what? That is the constant 3.14. K is what? T square by r cube ratio, that is the k, and r is what? The distance, that is the radius between planet and sun, distance between planet and sun. Okay. So here if you see this equation, then one thing will be understood here. What? 4 is a pure constant number. Okay. M is the mass of that particular planet. So mass always remains constant, that will not change. So this m is also constant. Then pi is also one constant. 3.14 is the value, constant value of pi. So pi is also constant, and k is the ratio of t square by r cube. It is also constant for one particular planet. Okay. So these all values are constant except r square. Okay. Because it's changing planet to planet. Okay. So we can write here 4m pi square by k. These values are constant. Okay. So which value is changing planet to planet? Only radius. Okay. So from that Newton conclude this force present which is helpful for the circular motion, that is the centripetal force, which is inversely proportional to the square of distance between planet and sun, and that force is nothing but the gravitational force. Okay, so in that Newton's gravitational law, Newton concludes that the force of attraction between any two massive bodies in the universe is inversely proportional to square of distance between two planets. Okay, so by using this uniform circular motion and magnitude of centripetal force, Newton actually studied Kepler's third law. Okay, and from that, by studying centripetal force, actually meaning of centripetal force, after that Newton concluded that a centripetal force is nothing but the attractive force between two objects, that is the sun and the particular planet, and this force is inversely proportional to square of distance between that two sun and object. Okay, so next topic is we will see later. Next topic is Earth's gravitational force. Okay, so from the childhood we are very curious about that. Okay, when we are throw a ball in the sky, then after some time that ball again fall on the ground. Okay, so one question there is also came in our mind, that is what, why that ball does not go away. Okay, that ball don't have to fly, don't have to put down again on Earth. Okay, so we are very curious about that, why such things are happen. Okay, because reason behind that is Earth's gravitational force. Due to the Earth's gravitational force, what happen, objects are fall on towards Earth surface. Okay, now we know our Earth is, suppose this is our Earth, this is Earth center. Okay, so it is not exactly circular, but we consider it is a circular. Okay, now this is the center of Earth, and now this is center of Earth. It is the point where we consider that this is the center of mass. Center of mass means what? Simply a point where we consider, for our simplicity, that whole mass of that particular object is gathered in this point. Okay, so we consider that this is the center of Earth, and here all the mass of Earth is gathered. Okay, so now this Earth's gravitational force is always towards the center of Earth. Why center of Earth? Because the whole mass of an object or Earth, we consider it is situated at the center of Earth at this point. Okay, so generally what happens, this gravitational force, we know it is always attractive force. It always attracts other objects towards us. Okay, so generally when we are here and we throw an object in upward direction. Okay, so generally when we are throw in upward direction, but Earth has a tendency to attract every object towards its center. Okay, so generally what happens, as we try to throw any object upside, then simultaneously Earth's gravitational force pulls it downwards. Okay, pulls it down continuously. It tries to pull it downward towards the center of Earth. Okay, so due to that, what happens, at a particular point, that initially its velocity is very high. As we throw any object upside, at that time initially its velocity is high, but as it gains some height, its velocity continuously goes on decreasing, and one particular point it reaches here, its velocity becomes 0. Okay, because simultaneously Earth's gravitational force pull that object towards its center. Okay, and when it reaches maximum height, where its velocity becomes 0, then again it will fall down towards Earth's surface and it will fall on the ground. Okay, so why this species happen? Because due to the Earth gravitational force, and we know Earth is also one massive body. This object we are thrown, that is also one massive body, and there is also force of attraction in between them. So Earth has a tendency to attract every object towards the center, because I already told you, at the center of mass, whole mass of the body, whole mass of the Earth is what? Gathered. Okay, so that is why every object it try to attract with its center. So that is why when we throw any object upside, that will be fall down toward the Earth's surface. Now one another question will come in your mind. Okay, whatever the natural satellites that we are sending around the Earth, and suppose this is a moon that revolves in this particular orbit. Okay, this is the satellite. Suppose this is the moon orbit. Okay, now one question then after studying that should be come in our mind, that why not these satellites are fall on the Earth's surface, and also why not this moon is also fall on the Earth's surface. Okay, so simply what happen here, when we throw any object upside, then its velocity becomes zero at a particular height. But now if we study the case of moon and natural satellite, then we will see that they have somewhat horizontal velocity. Okay, they have somewhat horizontal velocity. Due to that, we know when object has a horizontal velocity, then due to this centripetal force, it will be possible to move them in a circular manner. So they can perform circular motion over here because of velocity. They are not steady. Here what happens, its velocity become zero. That is why this object fall down toward the Earth's surface. But moon and our satellites are not fall, because they have minimum horizontal velocity. Which minimum? Because if you want to move any object in circular orbit around the Earth, then we have to give that object minimum velocity, then and then that object can move around the Earth, and that minimum horizontal velocity is present in case of artificial satellites and also in case of moon. That is why moon and satellites are not fall on the surface of Earth, but any object as like a stone, as we throw upward side, then that will be fall on the surface of Earth. Okay, so that's about Earth gravitational force. The next topic we have to see, that is Earth gravitational acceleration. Okay, so in last year we have studied about acceleration. Acceleration is simply a change in velocity with respect to time. This is simply called as a acceleration. And also we studied Newton's second law. In that, Newton tells us that if you apply force on any object, then acceleration produced in a particular object. Okay, so Newton's second law also tells that acceleration produced in an object is directly proportional to applied force. Okay, that is also a statement of Newton's second law. Okay, so we know Earth's gravitational acceleration, simply meaning is what? Acceleration due to the Earth's gravitational force. What? Acceleration produced in an object due to the Earth's gravitational force is simply called as a acceleration due to gravity. What? Acceleration produced in an object due to Earth's gravitational force is simply called as a acceleration due to gravity. Okay, we know Earth have attractive power. Okay, that is the gravitational force, and it apply gravitational force on any massive body. Okay, so now this is a one object. Okay, it is initially in steady condition. Now what happen if I remove my hand? Then what happen? Earth will apply gravitational force on this object. That object will fall towards Earth center. Okay, so simply what happen, initially this object in steady state means velocity is 0, but as I remove my hand, acceleration produced, its velocity goes on changing. So that is why acceleration produced in this object due to the Earth's gravitational force. Okay, so due to the Earth's gravitational force, generally what happen, acceleration produced in an object. Okay, so that's called as a Earth's gravitational acceleration, acceleration produced in an object due to the Earth's gravitational force. Now here we know, according to Newton's law, that force of attraction is given by G capital M small m divided by R square. Okay, where G is gravitational constant, capital M is mass of Earth. Okay, capital M is what? Mass of Earth, and this small m is what? Mass of object. Okay, mass of object. Suppose this is object, its mass is what? Small m. Okay, so this force of attraction will be equal to G capital M small m divided by R square, and R is what? Distance between this object and Earth center, that is the R. But we know, according to Newton's second law, F is equal to mg. Actually F is equal to what? ma. But at surface of Earth, A is equal to G. So that is why we have to write as, instead of ma, we write F is equal to mg. Okay, that you already know, you are already studied in last year. Okay, so this F is equal to mg. Now this F is equal to what? Mg. So instead of this F, we write here mg, and right hand side we write as it is. So this small n get cancel over here. So remaining is what? G. Small g will be equal to capital G capital M divided by R square. Okay, so if object is very near to Earth's surface, okay, so your R will be nearly equal to capital R. Okay, because object is very near to the Earth's surface, so that distance is not matter, we neglect them and we take this R is equal to capital R, radius of Earth. So your G will be equal to capital G capital M divided by R square, where this G is called as a acceleration due to gravity, Earth's gravitational acceleration, that is indicated by letter small g. The formula of small g is capital G capital M divided by R square. Okay, where capital G is Earth's universal gravitational constant, capital M is mass of Earth, and R is radius of Earth. So small g is equal to capital G capital M divided by R square. Okay, so what is the value of G on the surface of Earth? That is capital G have value 6.67 into 10 raised to minus 11 Newton meter square. Okay, then capital M is a mass of Earth, that is 6 into 10 raised to 24 kilogram, and R is a radius of Earth, that is 6.4 into 10 raised to 6 meter. Okay, it's square. If you calculate these all things, then we will get answer G is equal to 9.77 meter per second square. That is the value of acceleration due to gravity on the surface of Earth. Okay, simply look at that. Earth's gravitational acceleration means what? Simply acceleration produced in an object due to Earth's gravitational force is simply called as a Earth's gravitational acceleration, and it is denoted by small g. Formula of small g is capital G capital M divided by R square, and its value on the surface of Earth is 9.77 meter per second square. But this value is not remain constant everywhere on Earth. It will be changed. Okay, on the surface of earth also it is not remains constant. On the equator it is different, on the pole also it is different. Also we go upside from the earth surface height, then also it change, and also we go down toward the center, also it will changes. How the value of these changes, that we will see in next lecture. Thank you.